So we have already discussed about this lating system or lating phase diagram, right? So I told you this point is called your eutectic composition. So the alloy which will form is called eutectic alloy. Okay? So if an alloy composition is below this one, we will call hypoeutectic alloy, and if an alloy whose composition is greater than this is called hypereutectic alloy. Right? So we can have hypoeutectic alloy, eutectic alloy, and hypereutectic alloy. So since we have different alloys, so microstructure evolution will be also different. So now we'll discuss about the microstructure evolution in this. Suppose I will take a composition of this one. So this composition is nothing but hypoeutectic alloy composition, right? Because this is below this one. Suppose I want to draw the microstructure over here. I will start from here, then I will move down. So this is in this condition, I will be having only liquid. So the thing will be what? This is the circle. You can show liquids. That. But the moment you go down, we have solid and liquid both, right? That means a solid is getting nucleated, that is alpha. So at this point, I can draw like this. I will be having liquid, but I will have some solids. So this is your alpha, and this is your liquid. Right? Now the moment I will go below this temperature, actually you have to remember this line is called eutectic horizontal. This is a horizontal line, so this is an eutectic horizontal. So below this temperature, this liquid will transform into alpha plus beta, but this alpha will remain as alpha below this temperature. Right? So what will be happening in a situation like this? We have now, so finally we have solids, that means grain and grain boundaries will be available. So I can draw grains. So I will having alpha. Fine, I can draw. I will having this alpha first. So the alpha is present over here. Done?
Yeah.
Then I will have mixture of alpha and beta. So I will have alternate layers. Suppose my layer are like this. Fine. So this is alpha, this is beta. This is alpha, this is beta. And these are your layer alpha, which is this one. This is, or this is pro-eutectic alpha, you can say. So one alpha is present in the laminar form, but one alpha is present in this one, spherical form kind of thing. Not exactly spherical, but so suppose when suppose I will take a composition of this one, eutectic composition. So how the microstructure will evolve? So I will start from this point. I can join this one. So here I will having what? We will be having liquids. Only liquid I have. Fine. Then I will move to this point. So you can see below this point, this liquid is decomposing into alpha plus beta. So liquid is transforming into alpha plus beta. Alpha plus beta is solids. So I have only. So at this point, okay, at this point I will be having. So I will be having alternate layer of alpha and beta. It is okay? One layer is alpha and the layer is beta. Only solids. Then suppose I will have a composition of this one. Suppose this one. And this composition. That means this is hyper-eutectic composition. So how the microstructure will go? We will have only liquid. Right? Then at this point, this is the two-phase region, liquid and beta. So some beta will nucleate inside the liquid. So I can go. I have liquids and some beta phases will be here. So this is beta. this is the liquid. Fine. So finally, when I go below this one, this liquid will transform into alpha plus beta, and beta is already there. Fine. So at this point, I am having like this structure. So grain boundaries. Okay. So I am having alternate layer of alpha plus beta. But I have some beta pairs. Is okay? These are beta. So eutectic beta, and this is a lamellar alpha and beta. Okay, you can pause.